Hello everyone. In this video we are going to discuss about extended transition function for DFA. Transition function for DFA takes two arguments as input and one as output. So delta is a transition function. It takes two arguments. They are current state and input symbol, and it returns next state. That is, if we are in state Q and A is the current input symbol, then the next state of DFA is P. Means we can write like this: delta of Q comma A equals P. So transition function is found for the single input symbol. Extended transition function is represented by delta cap. It is for here the second argument is a string. Okay, transition function means single input symbol. So extended transition function is found for the string. So delta cap of Q comma W equals P. So here Q is a current state and W is a string. So P represents, after reading all symbols of W, the state of DFA. So Q is the current state and W is the input symbol, means after reading all input symbols of W, then we will be in state P. That is represented by the extended transition function, that is Q. From Q to P, by following the number of input symbols. Here so many states are there in between Q and P. So after reading all the symbols of W, if the DFA is in P, means it can be written as delta cap of Q comma the current state comma the input string is equal to P. So this is the formal definition for extended transition function. So the basis condition is delta cap of Q comma epsilon is equal to Q. That is, without reading any input symbol, if we are in state Q, then we will still remain in the same state Q. So here the Q is a current state, epsilon, empty string is the string. So without reading any input symbol, we will still remain in Q. This is the basis condition. So for the induction step, we need to take some large string W. So the W is in the form of XA, where A is the last symbol of W and X is the remaining symbols of W. That is, X represents all symbols of W except the last one. For example, if W is 0, 1, 1, 0, then X is 0, 1, 1. All symbols of W except the final symbol. A is the final symbol 0. So it is written like this because this is the recursive definition. So if we want to find delta cap of Q comma W, delta cap of Q comma W, this can be written as delta cap of Q comma X comma A, because W can be written in the form of XA. So delta cap of Q comma X must be find out first. So, assume that delta cap of Q comma X equal to P. That is, after reading all symbols of X, if we are in state P, means then delta cap of Q comma W is delta this P, this step is P. So P comma A. So if we want to find delta cap of Q comma W, first we need to find delta cap of Q comma X. This can be find out using the recursive step. Then we have to substitute that here. So delta of P comma A, this is the transition function. Delta cap means extended transition function. Delta means transition function. So finally we will get some state as the output. Then we need to know about language of a DFA. So if DFA A is equal to Q sigma delta Q naught F, then the language of the DFA A can be represented like L of A. L of A is equal to set of strings W. Language means set of strings W. Here the condition is, if we find delta cap of Q naught, that is start state comma this W, then we should have some final state. It should belong to, the output should belongs to the final state F. So L of A means set of strings W such that delta cap of Q naught comma W, that is the extended transition function for W, should reach the final state. Then only we can say that W is accepted by L of A, otherwise it is rejected by L of A. Now we will see an example. So example problem for DFA is construct a DFA to accept all strings. that start with 1 and end with 0, and we need to check whether 1010 is accepted by our DFA or not. Since 1010 is starting with 1 and ending with 0, starts with 1 and ends with 0, it is definitely accepted by our DFA. So this is the DFA for this problem. It starts with 1 and ends with 0. It can accept all strings starting with 1 and ending with 0. So here Q0 is a start state. From Q0, 1 goes to Q1 because the strings should start with 1, and there is no transition for 0 from Q0 because the string should not start with 0. So there is no transition from Q0 for the input symbol 0. Then in Q1, from Q1, if 0 is the input symbol, then it should go to Q2 because the string ends with 0. 10 is also a correct input string, so it should reach the final state. Suppose in Q1, 1 is the input symbol, it should remain in the same state. That is, after reading 1, for any number of 1s, it should remain in the same state. If the input symbol is 0, it should reach the final state. Then in Q2, if the input symbol is 0, that is, after reading some 110, for example, if we have already read 110 means we will be in state Q2. Now the next input symbol is also 0. The meaning is this string is also ending with 0. So it should remain in the same final state. Because the string starts with 1 and ends with 0. So it should remain in the final state. But from Q2, 1 is the input symbol. That is, after reading some symbols, 1 is the input symbol. So 11001, for example, consider this 1100. 1 is the input symbol, means again we need to read one more 0 to reach the final state because all strings should end with 0, so that it has to go to the previous state, because from this state only by following 0 we can reach the final state. So from Q2, if 1 is a input symbol, it should go to the previous state. Then for the next input symbol 0, it can reach the final state. So this is the DFA for accepting all strings which are starting with 1 and ending with 0. Now we can draw the transition table. Q1, Q2, Q3 are the states. Q1 is the start state. Sorry, Q0, Q1, Q2. Q0, Q1, Q2 are the states. Q0 is the start state. Q2 is final state. So it should be represented by star. And input symbols are 0 and 1. Q0 and 0. There is no transition for Q0 and 0. Q0 and 1. The next state is Q1. Q1 and 0 is Q2. Q1 and 1 is Q1. Q2 and 0 is Q2. Q2 and 1 is Q1. Now we need to check whether 1010 is accepted by our DFA. 1010. So we can use the extended transition function for checking the string is accepted by our DFA or not. So 1010, first we need to write the basis condition. So delta cap of Q means here the starting state of the DFA is Q0, comma, first we need to consider epsilon. Okay, so delta cap of Q0 comma epsilon is equal to Q0. If we are in state Q, we will still remain in Q, here Q0. So delta cap of Q0 comma epsilon is Q0. Then in the second step we need to consider one input symbol, first input symbol of the string, because it should be find out recursively. In the first step we need to take 1, then 10, then 101. In the final step we have to consider full input string. So Q0 comma 1 is equal to here. So this is the, here W is 1. So we need to refer the induction step. So in induction step W should be written in the form of XA. XA, so how to split this 1? 1 is W, and here A is the last symbol of W and X is the remaining symbols. So we need to split 1 in the form of epsilon and 1. Epsilon is X, 1 is A, right? Because 1 is A is the last symbol of W. X means remaining symbols. So here we can consider epsilon is concatenated with 1 because this is the identity element. Then this delta cap of q naught comma 1 can be splitted like this. So del of delta cap q comma x. So here we need to write q naught comma x is epsilon. So epsilon delta cap of q comma x. Here delta cap of q naught comma epsilon comma a. A means here 1. So delta cap of q naught comma epsilon is q naught, that is found in the previous step. So q naught comma 1. So what is delta? Delta means it is a transition function. You can refer the diagram or table. This table is delta only. So delta of q naught comma 1. Q naught and delta of q naught comma 1 is q1. So q1 is a result for this step. Then delta cap of q naught comma. Now we need to take two symbols. So 1 0 is equal to. So how to split this W now? A is 0. X means the remaining symbol. So 1. So delta cap of q naught comma x means 1 here. Then A is 0. Right? So here first we need to substitute delta cap of q comma x. So that is taken from the previous step here. Then we have to substitute delta of p comma a, that is found. So recursively we can find this step. So delta cap of q naught comma 1 is q1. So delta of here q1 comma 0. q1 comma 0. So delta of q1 comma 0 means it is q2. Then in the next step we need to consider three symbols. 1 0 1. So delta cap of q naught comma. Now x is 1 0, a is 1. So x means 1 0, then 1. So this delta cap of q naught comma 1 0 is q2. Then 1. Delta of q2 comma 1 is q1. q2 comma 1 is q1. Then for the final step we need to consider the full string 1 0 1 0. So now we have to write delta cap of q naught comma x 1 0 1. Then the last symbol is a, that is 0, is equal to delta cap of q naught comma 1 0 1 is q1. So q1 comma 0. Delta of q1 comma 0. q1 comma 0 is q2. Okay, so delta cap of q naught comma w is q2. So if you want to check whether the string is accepted or not, we need to refer this language. So what is the definition for language? The w belongs to L of A if delta cap of q naught comma w is in F. So delta cap of q naught comma w is q2. Since q2 is a final state, that is it belongs to final state F, we can say that 1 0 1 0 is accepted by our DFA. Since q2 is a final state, 1 0 1 0 is accepted by our DFA. Suppose instead of 1 0 1 0, 1 0 1 is given. This string starts with 1 but not ending with 0, right? It should end with 0 but it is not ending with 0. So what will happen? We will find out till this step. So what is the output here? This next state here q1. Since q1 is not a final state, we can write like since q1 is not a final state, 1 0 1 is not accepted by our DFA. So if you are considering the string starting with 1 and ending with 0, it will definitely reach the final state q2. Otherwise, for example 1 0 1 0 1 1 0, these type of strings definitely be rejected by our DFA. Thank you.